Hi, this is Dr. John Bergduff. Fractions are a common element at all levels of mathematics, from the very basic levels that we study in elementary school, all the way through college levels, even graduate school. Many people don't feel comfortable with fractions at the college algebra level, where the fractions may contain variables, because they never were terribly comfortable with fractions of plain numbers like you see in elementary school. We're going to take this lesson to build basics, the basics of working with fractions that can just consist of whole numbers for the numerator and denominator, and how to add and subtract those to build our comfort level. Now, when we talk about fractions, there's some basic terminology that we want to use. Let me start with a very simple fraction, about as simple as you can get. The quantity in the top is referred to as the numerator. The quantity on the bottom is referred to as the denominator. Probably at some point in this video I will refer to the numerator as the top and the denominator as the bottom, but there are formal names for these two positions. The easiest way to visualize a fraction is to imagine that you have some sort of geometric shape that you're cutting up into equal-sized pieces. The denominator is going to tell you how many pieces to cut that shape into, and the numerator is going to tell you how many of those pieces to take. The simplest place to start is with a circle. Think of the circle even as being like a pizza. If I'm dealing with the fraction 1/2, which I'm going to focus on in the picture on the left, simply imagine taking a circle and cutting it into two equal parts, like you're slicing a pizza down the middle. And the 2 refers to how many pieces you have. The 1/2 tells you to take one of those pieces. So I can have a geometric picture of the fraction 1/2 by taking simply just one of those two pieces. If I want to think about a fraction like 4/8, that would tell me to take a circle or a pizza, cut up into 8 equal-sized pieces, and select 4 of those pieces. 1, 2, 3, 4. Now, the first concept we're going to see is the idea of equivalent fractions. Notice that these two fractions geometrically represent the same area, so we say the fractions are equivalent. And right away we can learn a couple important lessons. If we start with the 1/2, notice that if we were to multiply the numerator by 4 and at the same time multiply the denominator by 4, the resulting fraction would be 4/8. What that says is taking a fraction and multiplying the numerator and denominator by a whole number other than 0, so you're not dividing by 0, that will result in an equivalent fraction. Looking at this a second way, starting with the 4/8, on the other hand, we can also recognize that the 4 factors as 4 times 1 and the 8 factors as 4 times 2. Remember, to factor a number means to write it as a product. And what this says is that if you recognize a common factor in a fraction and you have the same factor on both the numerator and the denominator, they essentially divide out. 4 divided by 4 is 1. So we can say that the 4/8 simplifies to 1/2. These are equivalent fractions, but the version of the fraction that has no common factor between the numerator and denominator is considered the simpler one. Now, hang on to those ideas. In a minute, we'll see where that becomes relevant with adding and subtracting. Suppose we want to add two fractions with the same denominator, 1/5 plus 3/5, using different colors on purpose. In both of these cases, we're imagining a circle or a pizza that's been cut up into 5 equal parts. 1/5 would represent one of those pieces, and 3/5 would represent 3 of those. Adding is simply putting together. So if you take the 1 piece and add it to the 3 pieces, you'll end up with 4 pieces of a 5-piece pizza And that tells you that 1/5 plus 3/5 is 4/5. The denominator doesn't change because we're not changing the size of any of these pieces. We're just combining pieces. 1 plus 3 is 4. Subtraction works very, very similarly. Suppose we look at the subtraction question, 5/6 minus 1/6. Now let me represent 5/6 in my picture of a pizza over here. This pizza is divided up into 6 equal parts. I'm going to take 5 of them. I'm coloring 5 out of the 6, like that. If adding means putting together, subtracting means taking away. This basically says take away one of those pieces. I can do that by simply taking one of those pieces and erasing the color and seeing what I have left. That gives me 4/6. So formally, what's happening is I'm copying the denominator because the size of the pieces is not changing, copying the denominator, subtracting the numerators. Now, notice that the 4/6 is a fraction that I think we can simplify because the 4 in the numerator factors as 2 times 2. The 6 in the denominator factors as 2 times 3. The common factor of a 2 divides out, and that gives you 2/3. How do we see that in the picture? Well, let me draw these lines differently. The red here is going to say, what if we had only cut this pizza up into 3 pieces? I want that to be really clear. Notice that the 4/6 that I had drawn in blue could also be thought of as 2/3 when I divide this up into 3 pieces. So simplifying fractions works in the picture. How do we summarize that? When we are adding or subtracting fractions with the same denominator, all we have to do is copy the denominator and add or subtract the numerators. Now, we can't spend our whole life drawing pizzas. That would be very time consuming. So let's see if we can build on this as our conclusion, our observation, our rule, and see if we can do a different kind of subtraction problem without a picture. Suppose we want to subtract 11/12 minus 7/12. Notice that these denominators are the same. If they are the same, you copy the denominator, and then you, in this case, subtract the numerators. 11 minus 7 is 4, so the fraction is 4/12. Now we'll take this as sort of an unwritten rule that no matter what, we will always look at whatever answer we get and ask ourselves whether it can be simplified or not. Let's see if we can simplify 4/12. Look carefully at the numerator and denominator and ask yourself, can those numbers be factored? Especially if you notice that the 12 factors is 4 times 3. You then realize that the 4 in the numerator is 4 times 1. And because there's a common factor of 4, 4 divided by 4 is 1, and the fraction will reduce to 1/3. So fortunately, we can add or subtract fractions with a like denominator even without drawing a pizza. Now, what happens if the denominators are not the same? For example, what if we want to do the addition problem 1/2 plus 1/3? I'm going to represent 1/2 in the circle or the pizza on the left. There's 1/2. And 1/3 with the circle on the right. 1 out of the 3 pieces. Adding means putting together. But as you can see, with these 2 pieces having different shapes, it is really hard to tell what you would get when you put those together. Geometrically, we can do this. What if we imagine subdividing the pieces we already have into smaller pieces? Look at this. Suppose in the circle on the right, I extend this diagonal line to the opposite side of the circle and do the same thing with the vertical line and the same thing with the other diagonal line, just extending those on. That one looks kind of sloppy. Let me try that one again. Like that. Notice that what I've done when I do that is I've divided the circle into 6 parts, and the 1/3 is the same as 2/6. Now, I could do something similar with the circle on the right if I put in 2 diagonals that kind of match the red diagonals I've drawn on the other side. Okay, forgive me if my artistry is not fantastic. Notice that the 1/2 can be written as 3/6, and the 1/3 can be written as 2/6. So what seems to be the case is if the denominators are not the same, maybe you can do something to get the denominators to be the same, and then once that happens, you can add the fractions. Let's explore how that can be done, because again, we don't really want to do this with drawing pictures all the time, but let's see what we could do. To add or subtract fractions with different denominators, first you're going to have to rewrite the fractions with a common denominator. What should that common denominator be? Use the least common multiple of the denominators. Well, that's an interesting word. What does that mean? The least common multiple of 2 numbers is the smallest number that is a multiple of both of those numbers. Let's explore this in the context of working a different example. Suppose we want to subtract, because this idea should work for adding or subtracting. We want to subtract 5/6 minus 7/9. The denominators are not the same. We need them to be the same. The suggestion is that we look for the least common multiple, but what does that mean? The multiples of 6 are basically what you get when you count by 6s. If you count by 6s, you'd go 6, 12, 18, 24, and so on. Adding 6 each time, so that 6 is 6 multiplied by 1, 12 is 6 multiplied by 2, 18 is 6 multiplied by 3, 24 is 6 multiplied by 4. The multiples of 6. Now look at the multiples of 9. Multiples of 9, counting by 9s, are 9, 18, 27, 36, and so forth. Notice that when I look at these lists, I see a repeat. That's a common number, a common multiple. And since that's the first multiple that we've seen in common, it's the least common multiple. The suggestion is that if we rewrite the fractions that we see with that as our common denominator, then we can have a common denominator and we can add or subtract. If we go back to the picture before, notice that comparing the 1/2 and the 3/6, we multiply numerator and denominator by 3. So to get that common denominator, comparing the 1/3 to the 2/6, we multiply the numerator and denominator by 2. Let's do something like that with 5/6 minus 7/9. So I need a little bit more space here. Let's go back to 5/6 minus 7/9. It's going to leave a little space. And remember that the common multiple I'm aiming for is 18. I do this. I ask myself, can I multiply 6 by something to get that common multiple of 18? What can I multiply 6 by to get 18? 3 would work. And as long as you multiply that on both the numerator and the denominator, you're fine. You're creating an equivalent fraction. 7/9, you'd like that to also be an 18. How do you get 9 to be 18? You can multiply numerator and denominator by the same expression, same number. If I multiply 9 by 2, I will get 18. What does that mean? Well, The subtraction question that I started with very simply could be rewritten, based on what you see here, as 15 over 18 minus 14 over 18. Now you have a common denominator. You can copy the denominator, subtract the numerators, and you've got it. Now, the process we use to find a least common multiple worked great as long as the numbers are 6 and 9 or something rather small. What if we get numbers that are a little bit worse? In a minute, I want to do some fractions that will have these two denominators, but for right now, I just want to explore how do I find the least common multiple, that stands for least common multiple, of 54 and 60. I don't really want to count by 54s and count by 60. That's way too hard. Fortunately, there's a nice and simple way to do this that we can take step by step. Let me put those steps in black. First of all, first thing we're going to do is factor each number into prime numbers. You may have remember seeing in an earlier part of your life factor trees. To factor means to write as a product, and what you do is you start with your number and you ask yourself, can I factor this in some way? 54 factors as 6 times 9. Now, each of those numbers can be factored, written as products, again. 6 is 2 times 3, 9 is 3 times 3. This little diagram I've drawn here is sometimes called a factor tree. It looks like the branches of a tree. When you get to all prime numbers as sort of the leaves on the tree, the product of those factors gives you the factorization of 54. 54 is 2 times 3 times 3 times 3, or using exponents, which is more efficient, 2 times 3 to the third. Now, do the same thing with 60. 60 will factor as 6 times 10. 6 factors is 2 times 3. 10 factors is 2 times 5. Those are already all prime numbers. If I gather the 2's together, that will tell me that 60 is 2 squared times 3 times 5. Step number 1. Now, step number 2. In step number 2, what we're going to do is list every factor one time that appears in either factorization. What do I mean by that? If I look at my 54 and my 60, I notice that the 54 has some 2's and some 3's, and the 60 has 2's and 3's also, but it also has a 5. What step 2 is going to ask me to do is to just simply list a 2, a 3, and a 5. What do I do with that? Well, let's see. If I have my 2, let me rewrite because I'm going to need this. The 54 is 2 times 3 to the third. And the 60 is 2 squared times 3 times 5. Okay? What we have done just now is we've just simply made a list of all the factors that occur in either one of these factorizations. And then, step 3, raise each of these factors to the highest exponent to which it occurs in either factorization. So I'm going to go back up here, and I'm going to look at the 2, and I'm going to notice that in the 54, 2 occurs only once. But in 60, it occurs twice. The highest exponent is a 2. I'm going to put on here an exponent of a 2. Looking at the 3's, in the first factorization, there's 3 3's. 3 times 3 times 3, 3 to the third. In the 60, there's only 1. The highest exponent to which the 3 is raised is a third. Take the 3. The 5 only occurs in one of those 2 factorizations, and the highest exponent it occurs to is simply a 1. So we're going to leave that as it is. That's step 3. Finally, step 4, multiply all of these factors, and that will get you the least common multiple. So the least common multiple of 54 and 60 will be 2 squared times 3 to the third times 5. Multiply all those together, and what you will get is 540. That's the least common multiple. Now, why is that important? Okay, let's suppose that we want to do an addition problem that involves these 2 denominators. Suppose we want to add 7 over 54 plus 11 over 60. Unlike denominators, all the work we just did allows us to figure out what that common denominator should be. We believe that the common denominator we should aim for is the least common multiple, which was 540. Now, just like in our very simple example, we can ask ourselves, what can I multiply the 54 by in order to get this common denominator? This one is not too hard. I think you can see that if you multiply 54 by 10, and as long as you do that in both the numerator and the denominator, that's legal, that would give you 540 in the denominator. The 60 might be obvious, but it might not be. So let me talk about that a little bit more carefully. To look at this, I could go back a screen, but I'd rather just recopy it here. I want to remember that the 60 is 2 squared times 3 times 5, and the least common multiple before you do all the work is 2 squared times 3 cubed times 5. Take a quick look there. When you look at the factored form, it can actually be easy to see what's missing from the least common multiple compared to the 60. So if you look at the 60, I see I've got a 2 squared, and the least common multiple has a 2 squared. 60 has 1 3, but the least common multiple has 3 3's. In other words, I'm missing 2 3's. I'm missing 3 times 3. I need to multiply by 9. Multiply by 9 on the numerator and denominator. The 5 is okay. I've got 5 in both of those. It's the 9 that's missing. Multiplying 60 by 9 would give me 540. So if I do that, I will have 70 over 540 plus 99 over 540. Finding the common denominator, which is the least common multiple, gives you the same denominator so that you can copy the denominator and add the numerators. The sum of those numerators would be 169. Does that simplify? Well, that could take some looking, but if you think about what the least common multiple consists of when you factor it, notice that it factors into factors of 2, 3, and 5. So if this is going to simplify, 2's, 3's, or 5's would have to divide into 169. if you just look at that, a little bit of work will enable you to see that 169 is not divisible by 2, 3, or 5, and that tells you that that fraction is actually as simple as it can already be. Let's do one more example. I'm going to skip over that slide. Suppose we want to add, or let's do a subtraction, just to verify all these same steps. Suppose we want to subtract 2 over 45 minus 5 over 18, and just talk through the entire process. So we obviously don't have the same denominator, so we're going to have to calculate the least common multiple of the 45 and the 18. We start by looking at the 45 and the 18 and factoring them. 45 factors as 9 times 5. 9 is not a prime number, it factors again, 3 times 3. So 45 is 3 squared times 5. 18 factors as 2 times 9. And the 9 factors is 3 times 3. So 18 is 2 times 3 squared. My least common multiple, I make a list of all the factors that show up in either factorization. I see some 2's, I see some 3's, I see some 5's. I take the highest exponent that each of those factors is raised to. The 2 is raised only to the first power. 3 is squared. That's the highest exponent that the 3 is raised to, and 5 only occurs once. Multiply those factors. 2 times 3 squared times 5 gives me a least common multiple of 90. That's what I'm going to aim for my common denominator. So, to get the common denominator, we look at the 2 over 45, and later we'll look at the 5 over 18, and we ask ourselves, what do I need to multiply the 45 by to get 90? That's probably not too hard to see. We can multiply by 2. What to multiply the 18 by may not be quite as easy to see. So look at how 18 is factored and compare it with how 90 is factored and see what's missing. You've got the 2 and the 3 squared, but you're missing a 5. So if it wasn't totally obvious to you, looking at the factorizations tells you that you should multiply the numerator and denominator by 5. Now, 2 times 2 is 4, 4 over 90. 5 times 5 is 25, 25 over 90, fantastic. I've got a common denominator, that's awesome. I can copy the denominator and subtract the numerators. Don't worry that you're going to get a negative number, that can happen. We're going to get negative 21 over 90. We ask ourselves whether that can be simplified any. We look for common factors between the 21 and the 90. And I think that I see a 3 in common. I believe I do. The 21, just leaving the negative sign out here, 21 is 3 times 7. 90 is 3 times 30. The 3's divide out, and the fraction simplifies to negative 7 over 30. Now, this video has a follow-up video. I'm going to show you the secret slide that I skipped over, and that I'm also going to give you a chance to work a problem like this on your own. Check out the next video.